Hello, welcome to Bare Metal Machine. I'm Jeff Audia. Today I'm machining these parts, these things, and I thought I would take an opportunity to make a little video on this because this part is actually a nice little example in the use of the Cartesian display. And they're almost identical, except one of them has these angle features, and so that's going to give me a chance to showcase the integrated rotary table also. It's a rather thin part, and thin parts can often be a challenge in machining, so we're going to need a fixture. The part has these 4 holes in the design, so I'm going to exploit that fact to make a fixture rather easily. So I'm just going to grab a slab of metal, drill and tap some holes in it, and we'll be off to the races. Now, I already have a fixture actually from the first time I did this job, but I need another one. And so that's when I realized that I had a chance to capture this process from start to finish. So this video is not about making the fixture, it's about making the part. So I'm just going to whip through the fixture production really quickly, just a few minutes, and then we'll get into making the actual part. Okay, so here's our little fixture here. It's just 5 holes, right? So these 4 holes here correspond to the 4 holes that are in the part itself. And this hole here, the one I bored last, that's 0, 0. So that's the origin, and that corresponds to this corner of the part. So the next time you set this thing up, you just indicate that hole as 0, 0. And you can use this edge here that I cleaned up last as an alignment feature to get it aligned with the x-axis, and we'll be needing that later. And so once again, these 4 holes, I forgot that I actually had an actual part. I didn't need to make my little 1-to-1 paper doll. Okay, so we'll just screw the rough stock down like so, and we'll be able to machine this thing. And let's clean this thing up a little bit. I'm just gonna hit it with an orbital sander. And there it is. Voila, instant fixture. Okay, so I'm going to do a roughing pass around the part using a 1/4 inch 2-flute solid carbide end mill. And I'm going to leave about 5/1000ths of an inch, or thereabouts, on every surface. And this isn't going to be a tutorial on the use of the Cartesian display. I'm just going to machine the part like normal. Look at earlier videos for that. Okay, now for the finish pass, I won't need to mess with the table clamps. I'm just going to go for radar 0 here, and I should be able to run around the whole perimeter without having to make a fuss about it. And I'll just keep the radar around 0. You know, plus or minus a few tenths would be fine. All right, here we go. Okay, all set. Now, in case you're wondering, that would have been a miscut right there. I temporarily went in the wrong direction in X, and I don't know what it is. Every now and then when I make that particular move, I go the wrong way. You got to focus, because if that had been touching a line, I would have violated the line. Okay, so we're all set here. Okay, so I finished running the parts of the first type. Now it's time to do the second part type, which you recall had some angled features on it. And to do that part, we're going to need to use the Integrated Rotary Table. Okay, so remember, this was the first part type I made, and it's one of these. And this is going to be the second part type, which is almost identical, except it has these angled features, right? And it's going to be one of these. This was from the last time I made these parts. So notice that it says reference 16.955 reference. It's because, first of all, this isn't a drawing, it's a sketch. But the customer, what they wanted was these offsets here, right? These points, 921.668. It just happens to be that, you know, when you connect these dots, you get that angle. And the same over here. So I just put the angles in the sketch as a reference so that when you see the Cartesian display rotating the part to make, say, this line parallel to the x-axis, you should see something like 16.955 degrees, or its complement in the display. So the part model's in the display. It knows the equations of all these lines, so it can compute these angles for us. And these are just there for me to check what the Cartesian display is actually doing. All right, this is just a reference. Okay, so the first thing you got to do when you set up a rotary table is find the physical center of rotation, okay, which I've done here. And then we're going to set our DRO to 0, And we're going to set the Cartesian display to match 0, 0. Now this is not the same as the 0, 0 origin of the part geometry, which I'll explain in a minute. Okay, so the fixture has advanced a little bit since you saw it last. I had to put these 4 holes in it, all right, just so that it will allow me to mount it to this subplate that goes on my rotary table. Okay, so here's the setup so far. We got our fixture mounted to the subplate, mounted to the rotary table. Now remember this surface here that I cleaned up way back at the beginning? That's going to be the surface we use to align the C-axis 0. So when this surface is parallel to the x-axis, that's going to be C-axis 0, right? Because this thing was just thrown up here, and it's just at some arbitrary angle the way it's set up. We need to adjust it so that this thing is parallel to the x-axis, C0, and then we'll be ready to go. Okay, so the Cartesian display gives us a convenient way to align this surface with the x-axis, right? It's the same thing that you would do if you were lining up a vise, except this will do it automatically by computing the angle that it needs to rotate the table to make that parallel to x. So we need a point here and a point here. Okay, so I'll take the first point. I'm just going to zero out the indicator here. Okay, and I'm going to go to Menu, System, C-axis auto 0, locate the first point, hit OK. Now we got to go to the second point. Okay, re-zero the indicator. Okay, good. Get the indicator out of the way because the table's about to move. All right, so it computed the angle that it needed to rotate to, and then it made the rotation. Now let's just check it, just to be sure. Okay. Zero out the indicator. And it looks pretty good. It might be out maybe a half a thousandths. All right, so we'll call that good. That is now C-axis 0. Okay, so once again, what I did was to align that surface with the x-axis, I put the indicator in the location of the first point, and I zeroed it out, and I went to Menu, System, C Auto 0, locate first point, hit OK. I'm already at the first point, so OK. Locate the second point. You just move, an arbitrary amount in X. The longer, the better. It doesn't matter. And then move Y to re-zero the indicator. All right, right there. And then locate second point, hit OK. So, OK. Now the table's going to move, and it's going to reset C to 0. It's at 0 degrees. Okay, next we need to pick up the part geometry origin. So we'll indicate that 0, 0, just like we did before. Okay, so the next thing we have to do is translate the geometry so that it has the right relationship with respect to the physical center of rotation. So you saw a second ago that I had the indicator right over this origin here, right? That hole that represented the 0, 0 of the part geometry. And that hole is actually at these offsets away from the physical center of rotation that we called 0, 0. Okay, so now I'm just going to go to Menu, System, Translate, Tool Position. So it's going to take the current tool position, which is where the indicator is, and it's going to use those as the geometric translation amount to move the geometry so that it has the right relationship to the physical center of rotation. Okay? Okay. And now notice where the part went. So let's get the part readjusted here. Right? So now you see that's the physical center of rotation. And this is the translation amount, right? So now whenever we rotate the table around, when we rotate the part, everything will be where it needs to be, okay? Because we have this translation in place. And it's going to work out perfect, you'll see. Just as an example, watch this. We'll go to Radar, Normal, and let's pick up one of these lines. Okay, so this line here, let's say we were going to machine that line. We would want that line to be parallel to the X or the Y axis so that we could machine along it. Okay, so I'm just going to go to Menu, and I'm going to say Align with X, right? And you might remember from the drawing a little while ago, it was 16.955 degrees. And you see that is now parallel to the x-axis, and we can move the tool along it and cut a perfect angled line. All right, and notice that, you know, the rotation is correct. So all the geometry is right where it needs to be. And so you can move the tool about the geometry even though you've rotated it with complete confidence. Okay, now for the finish pass. Full disclosure, a battery ran out in one of my cameras while I was doing the actual finish pass. So I'm just going to use an already finished part, and I want to run over it again and just go through the motions of how I did it. And this will actually be kind of good because I won't have to use any coolant. Okay, so here we go.
Okay, so there it is. That's what I would have done on the actual finished pass.